Okay, let's do the transformation worksheet. And hopefully you've tried to do this before you just jump in and say, I don't know how to do any of this. Okay, the first one. Okay, as I explained in class, inside stuff works horizontally, outside stuff works vertically. I want you to start with the parent function. And in this case, it's something squared. And so the parent function looks like 0 squared is 0, 1 squared is 1, and 2 squared is 4. Minus 1 squared is 1, and minus 2 squared is 4. If my units are 1 for every square, the parent function would look something like this. One of the points it goes through is 2, 4. Okay. Now, let's see. There's more on the outside than the inside, so I'll take care of, let's do the inside first. A minus 1, everything inside works horizontally and backwards. So minus 1, you would think it would move at minus 1, but it moves at plus 1. So I'm going to do the inside first. I'm just going to shift it or translate it as it's called technically. I'm going to move it right 1. So the one that was 0, 0 will be 1, 0. And the one that was at 1, 2, 1, 1 will be at 2, 1, and so on. Everything gets moved over 1 unit. This one was at 2, 4, gets to 3, 4. Minus 2, 4 goes to minus 1, 4. One more to the positive side, to the right. And I want you to put units on the graph. If you don't, I'll end up taking points off on your test, so get in the habit. Okay, now we got outside numbers. And some of you don't realize that you need to do them in proper order of operations. Now, this is times 2 and plus 3, and so we do them the times transformation first, and then the addition translation second. The dilation of 2 times it, and these work vertically. So it does what it seems like it should. It moves everything twice as far from the x-axis. So I'm going to move the x-axis clear to the bottom of my graph, because this one that's up 4 is going to be up twice as far, up 8. So I need to have it a little higher. So this one that's at 0, twice as far from the x-axis, is still on 0. This one that was at 2, 1, that was up 1, goes to up twice as far, so it'll be up 2. And at 3, 4, it's going to be at 3, 8, twice as far from the x-axis. So if you want to, you can think of doubling the y-coordinates for all the points, keeping the x-coordinates the same. And I need to mark my units on the graph. So this is a vertical, because I could stretch it sideways, but this outside stuff works vertically. So it's a vertical stretch by a factor of 2, twice as far from the x-axis. And then we got plus 3, so I got to move the whole curve up 3. Now I could change my scale so that the boxes are worth 2 instead of 1, but I'm going to leave it the same scale, and it will go off the graph If I move the 1, 0 up 3, it's 1, 3. And 2, 2 becomes 2. 2 plus 3 is 5. And the other ones are going to be completely off. They're going to be up higher. They were at 8, so they're going to be at 3, 11. And negative 1, 11. So we're shifting it. We're doing a translation up 3. So where does 2, 4 end up? Well, first it got moved to 3, 4. Then it got moved to 3, 8. And then it got moved to 3, 11. Okay, next one. Oh, shift up 3. All right. This is also a parabola for a parent function. Okay. So make a parabola. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. If that's my y-axis. And my units are 2 1 for every box. Now I've got 2 things inside and 1 outside. I'm going to take care of the outside first. Outside is vertical, does what it says. It says take it down 1. So 0, 0 goes to 0 minus 1. 1, 2, 1, 1 goes to 1, 0. Those 2 points come down, and the 4s come down to 3s. 4 high goes to 3 high. Scaling is still 1 per square. Okay. Now I got the inside stuff, and I got 2 numbers, a 2 and a subtract 4. Everything works backwards, including the order of operations. Normally you do multiplication before addition or subtraction. But when you're working inside, you do things backwards. So addition and subtraction, you do first and then this. So it says subtract 4. Subtract 4, you'd think it'd move left 4, but it moves it right 4. So to make room for it, I'm going to move my y-axis over a little bit, and I got to take everything right 4. So this is 0 minus 1 goes to 4 minus 1. This 1, 0 goes to 5, 0. The minus 1, 0 goes to, I'm going right 4, so it goes to, minus 1 goes to plus, I didn't take it over 4, that's 3. Start again. 0 minus 1 goes to 4 minus 1. And this one goes here. I should have moved my y-axis over more. This one goes to there. The minus 1 goes to plus 3. The minus 2 goes to plus 2 and up 3. And this other one is over here at 5. That scale of 2, that second line is a 2. So I'm moving it right. It's a shift right of 4 because of the negative 4. That's the last thing I would do according to the order of operations. And the first thing I would have done was multiply by 2, but it's going to do opposite. So instead of horizontally stretching it by 2, it's going to compress it by 2. So this is a horizontal, not a vertical compression, but a horizontal compression by a factor of 2, or a half, if you will. I don't care which way you want to think of it. So now I can leave my axis here. It gets half as far from the y-axis, not from itself, but from the y-axis. So I have to take a look at each point. I'll look at the vertex, which is at 4 minus 1. It gets half as far from the y-axis. Well, right now it's 4 away, so it goes to 2 away. This is at 3 away, so it'll go to 1.5 away. This is at 5 from here, so it goes to 2.5 from there. This was 6 from the y-axis, 1, 2, 3, 4, 5, 6, so it goes to 3. And this was 2 away, and it goes half as far, so it goes to 1. So the compression is not around the axis of the parabola. It's the left side of the grid goes closer, and the right side goes, the left side gets closer, and the right side gets, they squeeze in towards the x or y-axis. Units on the graph: 2, 1, 2, 3, 1, 2. And so where did minus 1, 1 end up? Well, it went down to here, then it moved to there, and then it moved to there. So now it's at 1.5, 0. All right, the next one. The parent function this time is an absolute value, which looks like the absolute value of 0 is 0, absolute value of 1 is 1, and absolute value of 2 is 2. Absolute value of negative 1 is 1, absolute value of negative 2 is 2. If that's my y-axis, and that's 2, and that's 2, this is what it looks like. Got one number inside and 2 on the outside. I'll take care of the inside first. A minus 2 inside, horizontally, everything's opposite, so I got to go plus 2. So here goes to there, and over 1 up 1, over 2 up 2, 1, 2, and it should look like it's just moved, shifted, translated, right, 2. All right, now I got the outside, and I got 2 things out there, a minus and a 0.5. I'm going to do the minus first. Everything on the outside works vertically. So a minus is going to take all the positive y's and make them negative y's, and if there were any negative y's, it will make them positive. It's a reflection over the x-axis. So I'm going to move the axis up so I got room to draw this. And so that this 2, 0 will stay at 2, 0. This 1, 1 will go to minus 1, 1 minus 1. This one goes over the other side of the x-axis. This goes over the other side of the x-axis. This goes down below 2 and below 2. Looks like this. If my units on my axis are 2 here and 2 there, each square is 1. So this is a reflection over x-axis. And that's a vertical. It's working vertically, but it's taking it over the x-axis. And if it was down below, it would take it above. If above, it takes it below. Okay? And now we got to take care of the 0.5, which is vertically, and 0.5 seems like it would make it half as tall, and that's exactly what it does because it's on the outside, so it does what it says. So it's a vertical compression by 2. So this is on, and it's to the x-axis. So this is on the x-axis, is going to stay there. This is 1 off, so it goes to half that distance, half off, to compress it. This is 2 away, so it goes to 1 away. This was 1 away, so it goes to a half. 2 away goes to 1. If that's 2, and that's 2. So where does negative 1, 1 end up? Well, it moved to there, move to there, move to there. So it's at 1, negative a half. D. This is all, everything's inside. Parent function looks like it's absolute value again. So if I use 1, each square is a unit, it's 0, 0, 1, 1, 2, 2, and minus 1, 1, and minus 2, 2. Everything's inside. So now we've got to look at what would happen first. Well, I'd have to multiply by a 0.5 and by a minus, and then subtract the minus 1. If I'm doing it backwards, I'm going to take care of the minus 1. Seems like a minus 1 would take it minus, but it does the opposite, takes it plus. So this graph gets moved to the right 1. Every point gets moved right 1. Units are 1 per deal. Okay. So I took care of that. Now I got these two that are multiplied, which order of operations say do first, but since we're doing backwards, we're doing them last. And we can do either one of these first because they're both multiplied by a negative 1 and by a 0.5. So you got your choice, but those are working horizontally. I'm going to do the negative just because it shows up there first. So that means it's going to be a reflection. If it's times a negative, it's a reflection. And this is over everything that was positive x goes negative, and everything negative goes positive over y-axis. So this at positive 1, 0 goes to negative 1, 0. This one on the axis stays there. The one that was at plus 2 goes to minus 2, 1. 3, 2 goes to minus 3, 2. And we get it looking like this. And finally, the 0.5. Inside, so it works horizontally. 0.5 seems like it would squeeze it, but inside goes opposite. It stretches it, a horizontal stretch by a factor of 0.5 is a half, so it's a factor of 2. So it's twice as far from the y-axis. This is 1 away, goes to 2 away. This is on it, so it stays on it. This is 2 away, so it goes to 4 away. This is 3 away, goes to 1, 2, 3, 4, 5, 6 away. And this one that's 1 away on the other side goes to 2 away on the positive side. So it should look like it's being stretched horizontally. So where does 2, 2 end up? It went to there, went to there. No, went to there. It went over to here, then it got reflected to the other side to there, and then it got pushed further over. So it went to negative 6, 2. Yeah, negative 6, 2. Okay, let's do this one. Parent function, parabola. I'm doing these kind of quickly, so if you need to pause the video to keep up, that's fine by me. 1 squared is 1, 2 squared is 4, minus 2 squared is 4, minus 1 squared is 1. Looks like this. Units are 2, 2. What should I do first, the inside or the outside? I'll do the inside first. Plus 2, it's the only number in there. So horizontally, I'm doing the opposite, so it's going to move it minus 2. So I'll move my y-axis over a little bit and move this whole thing minus 2. Okay, got two things on the outside. I got a minus and a 0.25. And since they're on the outside, they do exactly what you think they would do. The minus is a reflection. Oh, should have moved this up. I'm going to move this up because I'm going to take this whole thing and reflect it over the x-axis. So ignore this one. This is my x-axis. This is my y. This is 2. This is 2. The one that's on the axis stays on the axis. The one that's 1 above goes to 1 below. One that's 4 above goes to 4 below. And then, let's see, this is reflection over x-axis. And finally, the 0.25, a quarter, gets 1/4 as far away from the x-axis because it does exactly like what it says in its time, so it works vertically. So if that's my x-axis and this is my y-axis, this was on the x-axis, so it's going to stay on the x-axis. This was 1 away, so it goes to a quarter away. This one was 1 away on the negative side, so it goes negative side a quarter of the way away from the x-axis. And this was down 4, so it goes down 1. And same over here. So it's a vertical compression. By a factor of 2 or 4, a quarter or 4. So you can write a quarter or 4, I don't care. And finally, this one. I put some parentheses in here to change the order that the operations would work. Now, some of you could distribute the 2, but you would be doing a different set of transformations. Ends up the same place, but I wanted you to do this one. So it looks like the parent's y equal x squared. So 0 squared 0, 1 squared 1, 2 squared 4. if that's 2, and that's a 2. Oh, I didn't say where the negative 2, 4 goes. Negative 2, 4 went to here, went down to here, and then went up to there. So it's at negative 1, 2, 3, negative 4, negative 1. Okay, back to this one. All right. The inside is the complicated part. So let's take care of that first. Order of operations. If I put a number in for x, since we have parentheses, we'd have to add the 2 first and then multiply by 2. So if we're doing this backwards, we're going to have to take care of the multiply by 2 because it was the last thing of those two things. And if it's times 2, we think it would stretch it horizontally by 2, but it compresses it by 2. So it becomes, that stays on the y-axis. That's 1 away, so it goes to half away, half away. This is 2 away, so it goes to 1 away. So it goes to 1, half, half, 1. If that's 2, and that's 2. By a factor of 2. Since I started working on the inside, and I'm now going to do the other inside, and normally the add would go first, but since it was parentheses and forcing the times to go first, we now go opposite of adding 2, which you think it would go right to, we move it left 2. So this goes to there, and to there, and to there, and to there, and to there. And so we did a shift, horizontal shift if you want to add more detail. Shift, left. Left tells me it's going to be horizontal. 2. And finally, the negative 1 on the outside is times, so it's causing a reflection over the x-axis. So all this is going to go down. So I'm moving my x-axis up so I have room for it, leaving my y-axis there. So this was up at minus 1.5, it was up 1, so it goes down 1. And that goes down 1. And that was up 4 goes down 4. And my scale is 2, 2 there, and it's a reflection over x-axis. And so where did 1, 1 go? It went to a half 1, to negative 1.5, 1, to negative 1.5, negative 1. And that's the transformations, the way I like to have you do them.